Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable Series. This episode of our Faculty Roundtable Series is focused on our Sunny Astounding Department of Civil and Environmental Engineering here at the USC Viterbi School of Engineering. I will be your host for today's session. My name is Paul Ledesma. I'm the Director of Undergraduate Admission for the Viterbi School, and I am joined by three fantastic faculty guides to kind of walk you through everything that happens in civil and environmental engineering here. So I want to get out of the way and let them introduce themselves, and we will start with our professor and chair of the department, Dr. Becerik-Gerber.
Hi, my name is Burcin Becerik-Gerber. As Paul introduced me, I just became the chair of Civil and Environmental Engineering Department about 3 months ago. I am a full professor in the department, and my research focuses on human building interactions and understanding the needs, desires, intentions, and habits and preferences of occupants in built environments, and modeling those requirements and integrating them into the design and operation of built environments, buildings, as well as infrastructure.
All right, and just who's ever next to me on the Zoom call here. Let's go to Dr. McCurry.
Sorry, it was muted. Hi, I'm Professor Dan McCurry. I've been here as an assistant professor for about 5 years now, started in January 2017. I'm on the environmental side of civil and environmental engineering. I mostly study water quality and water treatment, especially water reuse, which is a potential solution to water scarcity here in California. So we do a lot of research on how to turn something that sounds gross like sewage into drinkable water. And I teach classes mostly on water treatment as well.
All right, thank you. Dr. Savla.
Hello, everyone. My name is Ketan Savla. I've been here with the department for 9 years now, where I'm an associate professor. So research-wise, my interest is in designing algorithms and use of technology to make large-scale systems efficient and robust and resilient to disasters or other kind of disruptions. So systems such as transportation, power grid, or societal systems, right? And in terms of teaching, that also kind of reflects my research interest. So at the undergraduate level, I teach the introductory transportation course, which also touches a little bit on the economic side of systems.
All right. And last but not least, Dr. Wang.
Yeah, this is Qiming Wang. I'm assistant professor of civil and environmental engineering. My research primarily focused on manufacturing and mechanics of material structures to improve the resilience and sustainability of infrastructures for our society. What else should I say?
I think that's a great start. Thank you so much.
Thank you.
Perfect. So what we're going to do today for all of you that have joined us is kind of talk through as much as we possibly can about the department and the discipline and the research and what you can come to expect as an undergraduate in the civil and environmental engineering department. I'm going to lead the first half of the conversation with my questions to our faculty, and I'm going to lead that discussion and kind of get you some good context and help you understand our programs. And then towards the second half of the program, I'm going to open it up to you as our audience to ask your questions of our faculty. Now, for the time being, please hold your questions. We're not going to take any questions right now. So if you ask any questions, we're just going to dismiss them. So please hold your question for the time being. I will open up the Q&A towards the latter half, and then we'll get to as many of those questions as we possibly can. But I'm confident we're going to cover all the information that you need to learn more about our program. So let's get started. I'm going to ask what sounds like the most simple question, but probably going to be the most involved answer, the most complicated to answer. And it's probably going to take a tag team of all of you to kind of get into it. And I'm going to point this first at our chair, Dr. Bachrach-Gerber. What the heck is civil and environmental engineering? Or maybe you want to take civil and maybe Dr. McCurry could take environmental engineering, or talk about the discipline as a whole. When students are thinking about what they're studying, what are they getting into?
All right. I mean, that's a great question.
It's easy for me to ask. I totally get that. I'm taking the way out.
So I love our two disciplines because one of them focuses on the built environment and the other one focuses on the natural environment. Not to say that we don't think about the other one if we're in one or the other, but basically everything. I mean, how can I simplify this? From the moment that you wake up, you go to your bathroom, open the faucet, and you get a water to brush your teeth. So water, access to clean water, and distribution of that water through the water distribution system to you are obviously in a built environment. So we design those environments to drive your car, and we have Dr. Savla here focusing on transportation and infrastructure design. So everything that the built environment that you live in. So we are the people who are designing, engineering, and constructing that built environment. Along with, of course, I mentioned water, which is very important, wastewater, obviously also important, and air, right? So the air you're breathing and air pollution. So those are different areas of civil and environmental engineering that we focus. I'll just stop there and I'll see, maybe Dan can take on the environmental side and explain.
Sure, yeah.
Yes.
I mean, yeah, that was a great summary already, but yeah, in its most sort of traditional form, environmental engineering deals with human interactions with the environment, and in particular with water and air, and the study of their quality and how to improve it, both from, preventing pollution, things like that, but also on treatment of air and water to remove pollution from them. In the case of air, so that you can breathe a bit better. In the case of water, so you don't get sick from drinking untreated water. It's grown out of civil engineering because I think there's the common thread there of infrastructure. That when environmental engineering first started, maybe 100 years ago or so, the main concern was just moving water around. How do we do that? Through systems of reservoirs and canals and pipe distribution systems. And so that's why, even though it might not seem like the most natural fit to have civil and environmental together, they're both fundamentally connected to the infrastructure that allows humans to live in places like big cities. Environmental engineering has grown a little bit too in recent years and branched out into newer areas. Things like energy and climate are included in the umbrella sometimes of environmental engineering these days. So we have a couple colleagues in our department, Professors Sanders and Banweiss, who study issues more related to energy and climate, things like the urban heat island effect that are a little bit outside of the traditional core of environmental engineering. But yeah, that's most of what I've got.
Those are great combo. And I think I like the answer. Civil and environmental engineering is everything around you and everything you interact with, I think is what I got out of that. It's everything and every day. I love it. I love it. What some of you touched on this in your introductions on your areas of research, but maybe we can take it more of a top-down approach. What's the research happening in the department? What are the problems that civil and environmental engineers are trying to solve these days? And maybe if you all want to go in more in depth into your particular research areas, that would be good to flesh that out.
Who's first?
Yeah. Well, maybe I can. I mean, I think each one of us can introduce our research areas and go in depth, just as the department chair. Just information that we have 26 tenure track faculty doing research in the areas that we're talking about. And as a new chair, I tasked a group, a committee. We're going to be looking into our vision again, because our previous strategic vision has been done a while ago, and we're doing brainstorming sessions with faculty and students. So more exciting things to come to report, hopefully soon. But currently we have 4 research thrust areas. And the first one is sustainability. And Dan mentioned some of the names there: George Banweiss, Kelly Sanders, Amy Childress. I myself do some work on green buildings. So we're focusing on sustainability within the natural environment as well as engineered civil systems. The second area is water quality, access, and distribution. And we mentioned some of the names. Dan is a key member in this area. We focus on potable water and we consider the population growth and climate variability in terms of water quality, access, and distribution. The third area of research that we focus is disasters and extreme events. So we focus on both natural and man-made disasters. We have Professor Pat Linnett focusing on tsunamis. We have a new professor actually, Professor Nweke, focusing on, he's at the intersection of geotechnical and earthquake engineering. Another new professor, Professor Audrey Olivier, focusing on uncertainty quantification, focusing on specifically on structural health monitoring. And we have the fourth area, coupling of complex systems. Olivier is one of those people, but this is basically a study of how natural and engineered systems are coupled and how one impacts the other. So that's where we focus on. These are the four areas we focus in the department. Who's going next? Ketan, do you want to jump in?
Yeah, Dr. Savla.
So yeah, Burcin gave a very big overview, so I can be a little bit more specific on the areas that affect me directly. So I use a lot of algorithms in my research, and so naturally there's an overlap with a lot of optimization with computer science kind of stuff. So one example where I guess our research would be different than a typical computer science is there they would focus more on, let's say, autonomous vehicles, right? How to get an autonomous vehicle from point A to point B using all the sensors on board, etc., right? Whereas in a civil engineering context, we try to understand what societal impact will these technologies have, right? So if there are 50% of such vehicles are going to be autonomous vehicles, will it have positive effect? Not actually clear. And if it's positive, then how much positive? Is it worth the investment, right? So that segues us into a lot of other fields like policy and economics, right? So civil engineering, because of the scale, at the societal level, you cannot think of that as purely an engineering problem. It naturally touches upon economics. I mean, you want to allocate finite resources between several needs of the society, right? And policy, right? And so you do not want policies to be uninformed. You want them to be will be informed by engineering principles. And so transportation and other infrastructure systems are like power grid and water management, etc., are clear examples of that. So as far as my research are concerned, which also reflects the research of some other faculty in the department, Najm Eshkadi, for example, is one such, where we sit at the interface of more traditional engineering and more social science kind of flavor, kind of sciences. So maybe I'll let others go now.
Yeah, I can go next.
Yeah, go ahead, Jimmy.
My research area primarily on the materials and the structures, mechanics, material structures. So basically, this is kind of echo with traditional civil engineering with dealing with like structures of buildings, right? We build structures, so we need to deal with reliability of the structures and materials to resist this kind of extreme case mentioned by Burcin, or like fractures, damage, agents, these kind of things. So basically, this research area also echo with one of the NAE, National Academy of Engineering Grand Challenge. Actually, they list out this 14 grand challenge on the website. One of them is how to improve or restore our infrastructure in United States. That is because United States infrastructure actually is aging and failing. We don't have enough funding to repair them, actually, to replace them. So the challenge for our civil engineer is how to design better materials, structures, or future infrastructure construction to enable long sustainability or long-term resilience. So that's a long-term goal. So specifically, my research is try to figure out how to fabricate or manufacture these kind of new materials and structures for future infrastructure. So my research also echoes with this a very hot area called additive manufacturing, also called 3D printing of structures. So our approach actually is looking at nature to see how our neighbors on this planet, except human beings, like look at animals, microorganisms, and plants, all these other creatures, how they build themselves, how they construct their structures, how they design resilient structures to respond to external extreme conditions to them. right? How they maintain their well-being. So we got inspirations to design our own materials, the structures, to feature better resilience. For example, to resist fracture propagations, to resist damage, to resist aging, this kind of stuff. And also to figure out, can we design some material structures that can feature some previously unachievable functions, for example, self-healing. These kind of things that is very common in nature, but not very common in our synthetic material structures, like self-healing, self-generation, self-glowing, self-remodeling, these kind of functions. We try to realize these kind of natural functions in our engineered materials systems.
It's groundbreaking stuff. Self-healing synthetic materials is fantastic stuff, specifically in the additive manufacturing space. Thank you, Dr. Wang.
Yes, that is what we are doing.
Thank you very much.
So try to,
Oh
yeah, go ahead.
Sure, yeah. So on my side of things, so I guess I'll speak for most of environmental first, and then maybe drill in a little bit on what I do specifically. But touching on what Professor Savla said earlier, in civil and environmental, we're engineering for society. We're building like civilizations, not products. We're not making iPhones, we're making everything that's around you. And so naturally, I think it makes sense that our research sort of reflects what the societal problems happen to be wherever we are doing our work. And so here in Southern California, one of the greatest problems that we have is water scarcity, and it's getting worse because our main source of water is imported water from Northern California and from the Colorado River. Both of those sources are ultimately fed by snowmelt, and as snowmelt becomes a less and less reliable source of water as it's getting warmer and the weather's less predictable, we're in kind of a tough spot in Southern California with 90% of our water imported. And so a lot of the research that happens in our department is all about generating new sources of water. And so my colleague, Professor Amy Childress, works on seawater desalination, so studying ways to make it more energy efficient to turn seawater into drinking water, which is pretty clearly a civilization level challenge. And then my research is on wastewater reuse for the most part. So taking something that's kind of gross, wastewater, which is full of all kinds of pathogens and chemicals and stuff like that, and figuring out new types of technology for efficient water treatment to turn that into something drinkable, and ideally at a very low cost. Because the thing about water treatment is people are used to it being very, very cheap. The price of a bathtub of drinking water is about 50 cents. So it's just an unbelievable challenge when you think about that compared to producing some other product that you might go buy at the grocery store for 1/100th of the cost. So anyway, so in my lab we do a lot of research studying wastewater and its treatment to become cleaner, and so we do a lot of analytical chemistry. We use mass spectrometers and borrow a lot of tools from our colleagues in the chemistry department across the quad. And yeah, I don't know, try to make more clean water.
My only follow-up question, Dr. McCurry, is your typical unit of measurement in environmental engineering bathtubs?
Bathtub, yeah. No, the most typical environmental engineering water unit is one that may or may not be intuitive to people. It's the acre foot. It's one of these odd sort of antiquated imperial units. But yeah, when water managers are describing like the capacity of a reservoir or the flow of, per day in a canal or something, it's always an acre feet, which is, you can picture like 1 acre filled up foot deep. It's roughly, a football field to knee depth.
So it's about, how about like 300 bathtubs?
Probably more than that.
Now I've got bathtub in my head. I want to figure out what an acre for a bathtub is.
I think it's about 40,000 cubic feet. So probably on the order of maybe 1,000 bathtubs.
1,000 bathtubs. See, we're learning stuff. We're learning stuff here. I love it. All right, let's switch gears a little bit, talk about the curriculum, the undergraduate curriculum in particular. We have these students, the majority of our students are in high school. Some of our students are at other colleges and universities looking to transfer in. How can we describe, maybe from a 30,000-foot view, what is the curriculum for civil and environmental engineering? How does it start? What's kind of the arc? What kind of courses do they take? And if we could touch on what are, I think the question we often get is, what are classes like in college? They can only imagine high school courses right now. Who wants to take a start on that one?
I mean, the start is easy, right? Which is that it's pretty similar for basically all engineering majors, what you do your first year or so, right? I mean, I'm not the biggest expert in the room on this, most likely, but of course you can't become an engineer without learning, you know, calculus and chemistry and physics. And so that's where we start. And I think for all of the, Burcin, you can correct me if I'm wrong, I think all of our majors have pretty close to the same first year in civil and environmental. Is that true?
Yeah, in their freshman and sophomore years, you said the fundamental disciplines, right? Physics, chemistry, calculus. These are some of the classes they take, and then in their junior and senior years, they get a little bit more specialized. Structural engineering, geotechnical engineering, construction, environmental engineering, water resources, and transportation. And we do have different flavors, different tracks in our Bachelor of Science in Civil Engineering. We have building science, structural, environmental engineering, and we also have a minor in construction planning and management. So yeah, I mean, what is it like to take a class as an undergrad? It's a difficult question. I think we have a number of very talented faculty teaching these classes and bringing some of the real world instances to the classroom. So environmental engineering program, Dan, maybe you can talk a little bit more about the environmental engineering program.
Sure, yeah. So we just redid our curriculum in environmental engineering 2 or 3 years ago, mostly to update it to reflect the composition of our faculty, because we did a bunch of hiring around 5 years ago or so, which is when I came on. So we have around 6 new faculty in the last 5 years or so. And so we restructured the curriculum deliberately to give students exposure to each of us. So each of us, environmental engineering faculty, and there's 8 of us, you'll see at least once during your time as an environmental engineering undergrad here, sometimes twice. We also totally redid our intro class, which is the first environmental engineering exposure you get as a freshman. So there are now 5 of us who co-teach it, which is kind of fun. So we each do 2 or 3 weeks and rotate through. Then as you move up, you know, sophomore, junior year, there's of course some other engineering fundamentals you have to do, like thermodynamics and things like that. And then you get into the more specialized classes on, you know, water quality, air quality, things like that. And then finally, just like with civil engineering, your, you know, junior, senior year, you start to do a lot more engineering design, which is kind of a new thought process that people aren't typically used to outside of engineering, of, you know, how do you take the, you know, the information that we know from science about how a beam bends, or how a chemical, you know, how soluble it is in water or something like that, and use that to actually design, you know, a process or a part or something. And that's a critical part of any engineering curriculum, but something that you'll start to see mostly in junior and senior year.
I put a link into the chat for everyone to see out there in case you all want to take a little bit of a deeper look. You can see each of the individual disciplines and a 4-year plan for each of those. And one thing that I'll note and add on to this is that they all start with introductions specifically to engineering disciplines. And so you will be taking engineering courses immediately in your first year, which is a key difference between our programs and others. You're not just taking calculus and physics and science courses, where some other engineering schools will probably have you do kind of that front loading prerequisites. You actually have engineering courses up front, which helps you understand a little bit more about the discipline. It helps you find out whether you're in the right spot and helps you navigate through the specialization. Sometimes we get a lot of questions about those specializations. Which one's the right one? Which one's good for me? And you don't really need to worry too much about that now. That's something that you navigate as you go through the curriculum and you're exposed to more and immersed into more of that curriculum specifically. So it's part of a journey. Don't worry about having all the answers figured out right now. Can we talk a little bit about the opportunities that can happen afterward? Where do our students end up going after their undergraduate years? I mean, obviously, you know, not necessarily statistically, but anecdotally, where do your students go on to? Jobs, where do they work? Grad schools, where do they go? Any stories you'd like to share?
Yeah, I mean, I think there are a number of avenues. Most of our students go to the industry, I would say, and I just Googled because I asked this very question from our career services. We have an interesting group of companies actually, and I looked at the top employers, which is very interesting for me, but those are Microsoft, McKinsey, Accenture. So some of the consulting companies are there, along with construction companies like Parsons, Clark Construction, Jacobs, AECOM. These are also design and engineering companies. as well as some of them from the environmental engineering side go to Los Angeles Department of Water and Power, Edison, Southern California Edison, so energy and utility companies. Along with, of course, this is needless to say, some of them continue their graduate studies, right? Several of them go and do their masters. We also have an amazing program, PDP program, where you can add an additional year to your undergraduate degree to graduate from USC, not just with your undergraduate degree, but also with a master's degree. So that's to be eligible for that, you need to have a certain GPA and apply for it, but that's a great opportunity in 5 years to get your undergrad and master's.
Absolutely. I think that, go ahead.
Sorry, I would say that at least on the transportation side, I know many students get connected to the right opportunities during their late years through participation in some organizations. Like there is the ITE, so Institute for Transportation Engineers. So we have some part-time faculty here who organize networking events, take students on some tours. For example, we are blessed in Los Angeles that we have several transportation agencies. So there are lots of opportunities for students to have a visit. And so we have several part-time faculty who are very active in that arena. So I know at least on the transportation side, I'm sure, I know that it's also true in other programs as well. There are many networking opportunities in their junior and sophomore year.
Yeah. I mean, I also have a background in construction. So like Ketan mentioned, I can talk about construction. So we have faculty who are very well connected to the industry, construction industry here in Los Angeles or in California or in the nation. So we have several companies always recruiting from our graduates, from our student groups. We also we're very active also with CMAA, Construction Management Association of America, and we have several events. So there are several opportunities. I loved Paul's question because you're already thinking about where they're going to be placed. That's an excellent question. Yeah, so that's
definitely lots of opportunities.
Yes.
Yeah, definitely. I think statistically speaking, it's roughly 3/4 of our undergrads go straight into industry, with the remaining 25 on average each year are going into graduate school. But at the end of the day, some students are going back to graduate school after working. It just kind of depends, but just know that you have lots of opportunities and students are very successful. A quick note, Dr. Bachrach Gerber mentioned about progressive degree program. She mentioned applying, just so that you know, as students right now, you don't apply to that program now. That's only when you're a current student at USC. You're not eligible to apply to that program until you're a junior at USC. So know that that is a possibility in your future, but nothing to stress out about right now as far as the application process goes. Let's worry about applying to our programs first, and then we can talk about graduate school and the other programs as we go. I have one more question for our faculty, and then I'm going to open it up to you all for your questions. So start to get your questions ready. You can start to type them into the Q&A. I'll open it up to you now. But I will tell you this, we're going to keep all the questions related to civil and environmental engineering, to these faculty or to the discipline overall, not related to admission. I saw one question already pop up about admission. And so that question, we're going to push you to our admission information sessions. We have those twice a week. We have another one tomorrow. And in those admission information sessions, we can dive deep on the admission process, the application process, anything related to that, and we can answer all of your questions. But for today, we want to be mindful of our faculty's time and focus on their area of study, their area of research, or the curriculum in general. So we're going to talk about that in specific. So go ahead and start getting your questions. You can throw them into the Q&A session. The Q&A section also has upvoting processes. So when you see questions that you like, hit the upvote process. We're going to go down the most popular questions down, starting with the top, and then you can work your way in. My last question to the faculty before we get to these particular questions that are coming in the Q&A are all about this discipline versus other engineering disciplines. Sometimes we have students that are really undecided. They want to study engineering. They don't know what type. Is it civil? Is it mechanical? Is it aerospace? Is it computer science? So I want to give you your shot right now. Why is civil and/or environmental engineering the best of the disciplines, and why they should consider going in your direction rather than another engineering direction? Don't worry, I won't show the other faculty and the other,
I was
and the other
about to
departments.
ask.
I am gonna steal Dan's answer. We build civilizations, not products. I love that, Dan.
Yeah.
I think it's this really a great way of describing why it's important, right? We build, and I mentioned that as well, as civil and environmental engineers, we design, construct, and manage our built environment while protecting our planet's natural resources. So we rely on the structures and the technologies and the systems civil and environmental engineers engineer and build. So the solutions we come up with enable our lives, support our economy or the way of life. So these are really important points. I know that there's an interest in data sciences and AI and computing, but I strongly believe that push is going to saturate very soon, and we're going to be looking into the fundamental disciplines, because these are going to become the tools that we're all going to be using in the fundamental disciplines. And I can't imagine living without your highways or bridges, or breathing clean air and drinking clean water. So I don't know, that's my spiel. As well as, okay, let's not also forget climate change and extreme events, right? From, as I mentioned, to tsunamis, to the earthquakes, to hurricanes and tornadoes and flooding and everything we are experiencing in an increasing speed, wildfires. So civil and environmental engineers also find solutions to protect our society from hazards and disasters.
Yeah. And I guess I would just add two things. One, I hope this isn't too spicy to say, but as a civil and environmental engineer, you can always sleep at night. Rarely are we doing something that could be found, to be making society worse. The second thing is, I mean, I guess they're still negotiating the details, and I haven't paid enough, attention to it. But there's this infrastructure bill that's allegedly winding its way through Congress that was at some point $3.5 trillion. I don't remember how big it is now. Mm-hmm. There's never going to be a $3.5 trillion, app bill, right? Or bill for a new chemical engineering process or something like that. It's civil and environmental engineering is like right at the core of, our country's and the world's interests. And particularly right now when we're kind of having this societal realization that we need to really renew all of our infrastructure soon. Civil engineering, I think, and environmental is really going to be at the forefront.
We build civilizations, not products. I love it. We're going to put it on every brochure. We're going to make t-shirts with it. We're going to get it out there. I dig it. I'm excited for that.
Yeah, let me add one question, one answer. So if you quickly search this National Academy of Engineering Grand Challenging, they list the 14 grand challenges. There are 3 of them related to civil and environmental engineering. Those 3 including improve and restore infrastructure, and how to pro access to clean water, and how to achieve this carbon sequestration. I think. Yeah. Yes. So these 3 closely related to civil and environmental problems. So they are big problems. If you scroll through these 14 grand challenges, I cannot find any department except civil and environmental engineering department solve like more than 3, actually more than 2 big problems like CE department.
That's a great.
So think about it. So that means CE department really focus on this kind of big problems our society really face on, right? So we are solving big problems because we are important.
Absolutely. When the National Academy of Engineering got together and came up with 14 grand challenges, over 20% of those problems are civil and environmental engineering directly related. So absolutely. And for our applicants out there, you may remember, if you haven't looked at the app yet, we ask you a specific question about that, about the National Academy of Engineering on your application. So I think you just got a lot of really good information about stuff that sounds good to you. let's get to our questions from our audience. As a reminder for all of you that are out there, use the upvote feature. If you see a question you want to get answered, hit the upvote. That's going to push it to the top. I'm going to be going down that list. If you got more questions, keep throwing them in there. You never know what people are going to like to be asked. So go ahead and do that. And right when we did that, Chelsea got her question bumped up to the top. So Chelsea, are there any civil engineering internship companies partnered with USC? That's a good question. You know, it's funny, we talked about career outcomes earlier, but what we didn't recognize is that all those companies that we talked about are all taking interns as well. All those companies are recruiting for internships, co-ops, and full-time positions after graduation. We don't have a set list of companies, as maybe like a Midwest or a East Coast school would do with co-ops, because you don't have a set list of opportunities. You've got a ton of different opportunities, hundreds of companies coming to recruit you, and lots of opportunities. Is there anything else you all want to add on to that? Because students are interning regularly, nearly every single summer. I think we covered it. Okay, great.
I think, Paul, since there's an interest, I'm putting in the chat with Viterbi carriers, right? I mean, they can maybe check out that website as well. I know
absolutely
they're thinking about applying, but I think it's important to think about the end as well.
Absolutely. Michael, you could also put in Viterbi Admission /beyond, if you wouldn't mind, into the chat, because that gives you some more stats of relative companies that we talked about, lists of companies. It also gives you a little bit more on where students end up going with outcomes as well. Thank you for that. Let's get into Ethan's question just gets bumped up. What kind of study abroad programs does USC offer in civil engineering? How do they work? When do they occur? How do you apply? Where do you go? Yeah. Okay, Ethan, just so you know, we have study abroad programs across the university. They're open to all majors. We also have additional which our civil engineers can go on, environmental engineers can go on. We have engineering programs for all engineering majors, and there aren't specifically just overseas programs relative to individual majors. You have all the opportunities to get out there, so you're not limited to do that. Keep in mind, you've got lots of cool things, and civil and environmental engineers have done that. Now, that said, that answer is all pre-COVID. Currently in COVID, all study abroad programs have been put on pause. I think it makes sense why. We're getting excited about reopening study abroad programs as early as this coming summer. And so stay tuned for more programs that come up, but civil and environmental engineers can participate in all those opportunities, as well as maybe, Burcin, you want to talk about the special class that was created that you were involved in that has an international component as well?
I was waiting where I can jump in, I think.
Oh yeah, I was going to give it to you. It's such a specific thing. It's very cool.
So we created a new course. It's called Innovation in Engineering and Design for Global Challenges. So it's a course that is open to all engineering disciplines along with non-engineering discipline students, but it is actually in our department. It's hosted in our department. It is CE 486 with the department name and the number. And we focus on global challenges, right? We focused in the first 2 years on global refugee crisis. The third year was COVID, and this year they're focusing on sustainability issues. And this course takes students twice a year to a hotspot. So they've been to, for example, Greece for refugee crisis, and a couple of weeks ago they were in Alaska looking at environmental issues related to that part of the country. So I can put it in the chat if they want to have more information about this class, but it's a very unique opportunity for students who are not only interested in putting their engineering skills into action, but also are societal. They have a mind for societal, or they have a heart for societal impact.
Absolutely. Thank you for that. I apologize for going longer. I wanted to give the broader examples before you got to the specific one on the 499 class. So thank you. Reese asked a question about, can undergraduate students get involved in a professor's research? And if so, how available is that for students? Can you all talk about undergraduates involved in research in your department?
Sure. I think I probably have the most in our department in my lab. I'm looking at a couple of them right now. I think currently 5 in my lab. So there's a lot of different programs to support undergraduate research here. There's the Provost's Undergraduate Research Fellowship, which is something that any USC undergrad can apply to. And I've had several students get that in my lab, and it just provides a little bit of funding to work in labs. There's also a Viterbi specific program that happens, I think, at the very beginning of freshman year, where certain students are given a scholarship that I believe requires them to do a bit of research. Paul, you probably know more about that program than me. But I have one student on that program in my lab. And then there's just a new program has been added just this year called the CURVE program. I forget what the acronym stands for, but it's a way for undergraduate students to be matched with faculty labs for doing research. So I just got a couple new ones that way. So it definitely happens more so during the school year, it tends to be, than during the summer. Students tend to do internships over the summer, but if a student is especially interested in research and dedicated to it, it's not unheard of at all to stick around during the summer and do research in a professor's lab. My very first research journal article that came out of my lab, the first author was an undergraduate who joined up right away and helped put together my entirely empty lab and got a ton of research done in a short amount of time. So short answer is yes, there's a ton of undergrad research that happens here.
And I would also say that you don't have to go through some of these standard programs that Dan mentioned. You could approach a faculty informally. So I have three undergraduate students who work with me. One of them, she just approached me after my class, and she's been doing amazing work. Something that might end up with a peer-reviewed work. So yes, there are so many programs that you can latch on to right from the get-go. But even if you miss the bus, that's not the end of it. You can just approach faculty informally.
One more program, Dan covered the great spectrum, but we also have WISE undergraduate research opportunities, women in science and engineering. So I receive a number of students in my lab from that program as well.
When it comes to you all applying to the program, just know that your opportunities to participate in research as an undergraduate are incredibly flush. You have lots of opportunities, whether it's in a program or outside a program. And I think more students are doing research, not even in a program, as Dr. Savla mentioned, just getting involved, talking to faculty, because they're teaching your classes. You get to know them, find out what they're doing. Maybe you have an interest, and I'm sure that they can use your help. We do have additional programs that people can apply to as part of the application process. There are additional merit scholarships for research that we grant upon entrance. And then there's other programs like CURVE that Dan mentioned, where as an undergraduate, you can increase funding for those opportunities. So we want you to do research if you want to do research, and we're going to help you. Madeline asked this question: are there specific programming languages for environmental engineering?
I'm kind of the wrong person to ask, even though I'm the only environmental engineer here, because I don't do any programming myself. But I think that it's Python that they use. So they take Professor Ghanem's class with the civil engineers, and I believe that uses Python, but I'm not 100% sure.
He does, yes. He teaches that.
Yes.
All right, there we go.
My take on programming languages is, as long as you know one, it's very easy to move to the other. So you shouldn't be worrying about the specifics, even though we teach them here. But things will keep changing, so you should just be open-minded.
That's a good point. And that even came up a lot in our computer science faculty session. Like, oh, what language? Like, don't worry about languages. It's the last thing you need to worry about. You get in here, we're going to teach you how to think, teach you how to evolve, and you're going to be changing as it goes. So don't worry too much about that. There was a question that I put a link in and then it went away. So I didn't mean for it to go away, but Sydney was talking about urban sustainable planning minor. Sydney, that's a minor offered through the Price School of Planning and Urban Development. And that's a minor that anyone can take, including civil and environmental engineers. I put a link there for you to learn more about that. If that's something that's interesting to you and you want to couple it with your civil engineering degree or environmental engineering degree, you can, along with other things. It doesn't have to be related. You know, students minor in dance and music and theater and cinema. You have all sorts of opportunities at USC to engage across the academic spectrum, and you should, based on your interests. So have a good time with that. Braden just asked what computer science fundamentals are needed for environmental engineering. I'm not certain what kind of fundamentals. I don't think there are fundamentals necessarily.
I don't think you need any computer science knowledge at all entering our program. We'll teach you everything you need to know.
You got it. There you go.
Programming.
Very cool. Since environmental engineering, Sangeeta is asking this question, since environmental engineering problems are faced by the whole world, what tools does USC teach their engineers so that they will be successful in the international stage?
That's a good question, and a little bit of a tricky one, but I guess I would say all the fundamental tools that you learn about and all the science, don't care about national borders. Water treatment works the same here as it does in any country on earth. But I will say, let's say if you're interested in environmental engineering, and I guess my bias is always on the water treatment side, in let's say a lower income country context, that gets taught a little bit directly, water and sanitation in low income countries in a couple classes here. My E&E 200 class for sophomores, we touch on that a little bit. But also if you're interested in environmental engineering in international context, I think probably one of the most popular clubs in Viterbi is Engineers Without Borders, which is a national organization that has chapters at lots of different colleges, where we go and build and maintain primarily water and sanitation projects around the world. And so, for instance, I went with 5 or 6 undergrads to Guatemala in 2019 to work on a water treatment system for an NGO down there. And then with that same group, we're supposed to be, pending COVID travel restrictions and so forth, I think we're going to Malawi in Africa next year to again, start building a sanitation project. And you don't have to be a civil and environmental engineer to be in Engineers Without Borders, but it's definitely kind of the unofficial home department of that club. And so that's a good thing to look into if you're interested in international environmental engineering.
That's great. Sydney asked a great question. There are 2 programs in the department. One's in a degree in environmental engineering, and the other is a degree in civil engineering with an emphasis in environmental engineering. What's the difference between civil environmental and environmental?
I mean, it's just which classes you take. When I was an undergrad, back in the Midwest, there wasn't an environmental engineering major. And so I did the civil engineering with environmental engineering emphasis. So I took, a little bit of structural design, a little bit of transportation engineering. You're getting kind of the general broad, full view of civil engineering, and then maybe 3 or 4 environmental engineering emphasis classes, very much the same here. I think you can bounce back and forth between the 2 majors relatively late into your degree. I don't think there's a tremendous difference in terms of the early curriculum between the 2, so I wouldn't stress out that much. I would say if you get to about 2 years in and you're pretty committed to environmental, you should just do the BS in environmental. Or if you're interested in being more of a generalist and environmental is the specialty that has maybe a tiny bit more interest to you than the others, then you could do the other option. But it's nothing you need to commit to right now.
Yeah, a key distinction between our program and other engineering programs is that once you're admitted to one of our engineering programs, you're actually admitted to them all. You're not locked into it. And so you can change your mind between these. And as I said before, as you're immersed in the curriculum, you start to understand a little bit more, you start to feel a little bit better or stronger in one direction over the other. If you're trying to decide between civil with an environmental emphasis or environmental, the real question you want to ask yourself is civil versus environmental. And I was simplified even more going back to Dr. McCurry's comments in the beginning. Do you want to focus on the built world or the natural world? If you ask that simple question to yourself, where do you want to start off? Let's start with natural, start off with built. If you decide you want to go the opposite as you start getting through the curriculum, you definitely can. So don't, as Dr. McCurry again mentioned, don't stress out too much. This is just the beginning of it, and we're going to help you figure it out. And as you can tell, you have faculty here that will be helping you out. Zarin asked, are bathtubs a real unit of measurement? And I think we said no. We've already answered that question, I think.
No, we have plenty of goofy units in environmental engineering, but that's not one of them.
All right. Peyton, is it possible to double major in civil and environmental engineering? Is there a big disadvantage to doing this over the extra workload? I'm going to let our faculty answer this question after I say basically don't do that. There's no reason to get 2 undergraduate degrees that are so similar. This is usually asked by students because they can't decide. And as I just mentioned, pick the one that sounds good to start with. You could switch to the other. Any other advice, faculty, on that one?
That's a great advice. I mean, don't stress out right now. I mean, you can change your degree as you explore it more. I don't know, Paul, do you talk about the Freshman Academy? I think that's also a great way for students to explore different engineering disciplines.
Absolutely. As part of your first year inside of the engineering school, the majority of you will take our Freshman Academy class. And the Academy is a non-discipline specific introduction to the world of the profession of engineering, where you have a little bit of exposure to other disciplines. You're focused on, as Dr. Wang mentioned, the National Academy of Engineering's Grand Challenges. You start to kind of see the world from different perspectives and build community across your engineering discipline so that you're not so much siloed off as you would normally be in an engineering school. Keep in mind, when you're trying to decide, you're not locking it in. And usually when I get this question, it's because you're so worried about making the wrong choice. So realize you're not going to, you have flexibility, pick the one that goes with it. And at the end of the day, you might have extended education after your undergraduate years. There's nothing wrong with getting your undergraduate in civil and your graduate degree in environmental, or vice versa. These things happen all the time. You may find yourself involved in one or the other, or you may find yourself interested in a whole other discipline. So don't worry about it. Our program is built on that flexibility, and students find success because of that flexibility.
I would also mention there are a lot more other opportunities on campus. So we went through some of them, but there's a whole entrepreneurial activity going on campus, right? Dan mentioned correctly that we are not in the business of making products, but we definitely would appreciate more entrepreneurs in civil engineering. So something that would be nice to see.
Mm-hmm.
Awesome.
Yeah, I think it's important, Paul, maybe you can share the Office of Technology and Entrepreneurial Innovation and their link as well. I mean, we have an office focusing on this, as Ketan mentioned, and we have many students actually getting trained through that office as well. And we want to bring more entrepreneurship to the department as well. That's something we're thinking about, how we can train our students outside their classrooms to become more entrepreneur, more outside the box thinkers.
Yeah. You don't just live and breathe civil environmental. It's all about how you're going to be used as a base discipline and how you're going to be applying it to your profession in the world afterwards. Kevin asks, are there ways for students to get involved directly with helping to solve issues in the city through LADWP? I'll start with LADWP is one of those recruiters that's hiring for internships and full-time positions after graduation. They're always hiring. But any other things that you know going on with LADWP?
Well, yeah, and just to make it clear for like our non-Southern Californian friends here, DWP is Department of Water and Power, which is like a hugely powerful agency that provides all kinds of resources in Southern California. We send them a bunch of interns, I think, every year, it's safe to say, and plenty of our graduates, I'm sure, are employed there. As well as with other agencies around here. So there's also the Metropolitan Water District of Southern California that brings all the water from Northern California. We've sent people there. We've sent people to like Orange County Water District, for instance. They hire 2 or 3 interns from our department every year. So yeah, we're pretty closely connected with the municipal agencies in Southern California.
Very cool. Thank you. Aiden asked this question. I'm going to add on to it, slightly altered a little bit, but he's asking about, do you visit places downtown to talk about structures for classes? And I think maybe we can redirect this a little bit to like, how is a structural engineering class, how is it made real? What are the types of things you deal with to discuss certain structures? Is it going to real life buildings? Or do you want to talk about the structural lab in the sub basement? Maybe give shed some light on that.
Yeah, we have a great structural lab, which we built over the last 5-6 years. So we have all kinds of experimental facilities built into that. So shake tables, for example, if you want to check the integrity of structures or models. But we also have a lot of field trips. We not only go to downtown LA, but around LA. We take our students to construction sites. Professor Hank Kaufman has several visits to construction sites to show them the progress of a construction over the semester. I believe he goes 3 or 4 times. We also have a capstone class, of course, where we bring together building science students, civil students, as well as environmental engineering students, and they work on a project. We're very well connected with the industry. So Paul mentioned some of the internship opportunities. So there is going to be plenty for you to be exposed to how buildings are built or how infrastructure is built.
Awesome. Thank you very much. Madeline asked this question that I can actually give you some specifics on. How many students are in the environmental engineering program at USC? Well, each year our incoming class is slightly different. It changes, not an exact number, but for the civil and environmental engineering department, we bring in around somewhere between 35 and 40 students each year, and about somewhere between 15 and 20 of those students are environmental engineering. So it alters and changes around there. And then when I count environmental engineering, that's anyone involved in environmental or civil environmental, basically that combo of focusing on environmental. So as you can tell, a very small space where students are given the support that they need to be successful. Amaya, can you tell us more about the capstone class? Is that the class you were just mentioning, Burcin, or do you think that was a different one?
Yeah, that's the one. So we have 2 tracks, one for CE, one for E&E, and these are both licensed engineers teaching those classes, coming directly from the industry. And the idea there is giving you a brief, and then that's like the culmination of everything you learned in your in your 4th year, all the engineering principles that have been taught to you, and putting together a building together with your colleagues, your peers coming from different disciplines. So it's very hands-on and it's very design oriented. So you have to meet with the codes, you have to understand the codes, you have to, of course, implement all of the calculations that you have learned in different classes, and understand the build, whatever the infrastructure is holistically, not from one perspective.
Great. I have one final question for all of you, and then we'll close out for the evening. All of these students are considering applying to a number of different great institutions, maybe for civil and environmental engineering, maybe for other disciplines. Why should they continue to consider USC and the Viterbi School, and specifically the Sunny Estani Department of Civil and Environmental Engineering?
I mean, we think each one of us will have a different answer to this. But if you just look at who is here, we all come from different backgrounds. So I have a degree also in architecture. Qiming, you're coming with a mechanical engineering background, right? Ketan with electrical engineering. Dan, he mentioned that he did an emphasis on environmental engineering. So we are really a multidisciplinary group of people, and you are not meeting many of us who couldn't be here today. So we do think about civil and environmental engineering from a very different perspective. I didn't mention Qiming, obviously material science background, and he's innovating new materials for buildings and such. So we do think multidisciplinarily, and we do, I would say, we don't do traditional civil and environmental engineering. Our emphasis areas are quite non-traditional. So we look at the problems from a very different perspective. So that's what I would say. We also have a number of very energetic, research active faculty. Those are the two things that I would mention. Ketan, Dan, Qiming, add please to the.
Sure, yeah, I mean, so if you're going to study civil and environmental engineering, which is, the field that's all about enabling civilizations and building cities and stuff like that, like, would you want to do that in a big giant city on the coast of California or in the middle of a cornfield? I mean, it's a pretty, that's a pretty easy calculation for me to do. So that's one thing I would say. And the second thing is, I don't have any data for this. This is purely anecdotal, but I suspect that some of the very best instructors in Viterbi are in civil and environmental, just based on the feedback that I've gotten from some of our undergraduates talking about some of my colleagues and how beloved their classes are. Just for instance, my colleague Kelly Sanders teaches a class on energy that regularly gets 90 students, the majority of which are not in civil and environmental engineering, because the class has a reputation for being so fantastic that students come from all over USC to take it. So those are my two inputs.
All right. Well, with that, I think that's a fantastic way to close this out. I'm going to be respectful of our faculty's time, and I want to thank them for coming to speak to our prospective students out there. Dr. Savla, Dr. McCurry, Dr. Bachrach Gerber, and Dr. Wang, thank you so much for spending time with these students. And for all of you out there, thank you so much for visiting with us and asking your questions. We really appreciate it. If you have further questions, you can always reach out to us on email vadmit@usc.edu. You can call us at 213-600-9919. Come to our admission information sessions. We have another one tomorrow, and I got space in that. I'm leading that session. We'll have an in-depth conversation and get to all your questions there. You can go to our website, viterbiadmission.usc.edu. Mike will put a link in the chat for you there. And don't forget, your application's due soon. We're coming up on almost a month and a half till it's due for December 1st. Go to admission.usc.edu/Common App to complete that application. At least right now, put down USC as the school you're going to be applying to. Make sure you list one of the Viterbi School of Engineering majors as your first choice major, and we will be in touch if you ever need anything else. Thank you so much, everybody. Have a fantastic night. Faculty, again, thank you so much. I really appreciate it. Fight on, everybody.
Thanks
Bye-bye.
for having us.